Be happy. Look at me. Don't worry. Be happy. I give you my phone number. When you worry, call me. I make you happy. Don't worry.
Hello there, everyone. Welcome to this week's knowledge sharing session. Again, at the start, can we get some etiquette out of the way? Can we all have our mics and videos, please, if you don't mind, on mute? That includes you, John. It's not your part just yet. If you can mute your mic, that would be good. For the interactive parts, again, can we have the questions submitted via text in the narrative? If someone does want to raise their hand, you can raise it virtually within the app and speak when invited to do so. The questions will be filtered by vid as they were last week and introduced at the end of the appropriate slide. So don't get frustrated if it's not answered straight away. Just keep them coming in. Vid's going to filter them and bring them in at the right time. This is also recorded and the log is recorded of comments. So all those comments will be answered and will be shared in due course. And again, if we all try and talk over one another, it'll be carnage. So let's not do that. So the idea of these knowledge sharing sessions is to create a platform of knowledge within and connect our engineering community and share our knowledge and build on or capture our expertise across the specialist elements of ITT. The platform is share the knowledge and build on engineering experience. The response and input last week was great, so I'd like to build on that momentum. There was a good show from TDU last week, which is good. So we'd like to go forward, we'd like to have some TDU involvement and maybe some volunteers to do some of these knowledge sharing sessions. The reason we're doing this is the expertise tends to get lost when a member of staff leaves ITT. So we want to capture all that specialist knowledge that we have in-house. So we have very specialist arms within ITT of the ballasted track renewals, the ballasted P&C renewals. We have the deep tube renewals and the deep tube P&C, drainage and overnight BTR. There are other arms of the work. Mainly we had one roaring success, which was B2F, which was delivered. An example of that is a lot of that expertise has left the business and we're not sure if we still have some of the knowledge within the business that we may have lost. We also want to include the wider LU arm of the business. We want to include signals and power that work alongside us every week, week in, week out. In the past, we've had power appreciation lessons, signal appreciation lessons. We've done a Sherlock Points motor appreciation course a few years ago. It was one of the best courses I've done myself. It was very good and acting. It was done by Dave Petrovich. We actually had physically set up a set of points and get detection, which was very good. So ultimately, we all want to work on a collaborative engineering community, together, learn from one another, and be like one team. So how will we achieve this? On the next slide. So these knowledge sharing sessions will ensure specialist knowledge across ITT is captured. At the moment, we're multidisciplinary teams, like a Swiss Army knife. We're deployed to deliver all aspects of the business within each team. We're developing a great channel to spread the word and to gain exposure within LU and across TFL, the wider business. So that'll be revealed next week. We have a lot of specialist delivery skills within ITT that are unique to LUL. They're very different how we do it. Even our colleagues on Network Rail within the UK, that's completely different. Some challenges we see in other international metro systems. So I know in the past we've had visits to New York, and Ram's team had a visit to Paris Metro, which we found very good. We also want some senior leader team input into these sessions. Zach has very kindly agreed to do a session on CDM obligations within the project. So we just need to nail Zach down to a date. On to the aims. So the engineers to get a personal and share renewal expertise and share experiences. So we want to discuss the difficult jobs and the successful jobs, because both of them make us successful. We want to re-implement the cradle to grave, which we were doing with Track Partnership. It deals with the project life cycle, inception to completion. So as I said, there's some good stuff done within TP. It needs re-implemented into the ITT. So these knowledge sharing sessions will improve our safety and our quality. So we want to bring down the safety index and reduce our snagging and rework. That one last week, we done defect-free delivery. We want that to be our standard attitude at ITT. We should be aiming towards that and becoming defect-free delivery. So support material. So technical knowledge can be taught easily, like a stressing formula, that sort of thing can be taught to engineers. The thing that's hard is the soft skills. So it takes more time, and while we have the time now, I think this is a good platform to encourage those soft skills. We want to make the ITT contract a success story. We want to hit our SDIs, make this dream project come to fruition for Ali McLaughlin and John Lambert. So BPR is a great place to work. Anyone who's worked anywhere else will understand. You know, I've worked elsewhere. You come back, you can see what we do, which is really good. Our reliability is second to none, and that comes from hard planning and preparation in the weekend packs and gives us delivery certainty on the weekend. We need to improve safety and quality culture, and that'll get us to world-class delivery. So everyone needs to know how to approach delivery under the new terms of the contract. Delivery certainty from cradle to grave along the project life cycle. We need to see it through the pathway process, which is LU. We need to plan, deliver, and close out. We need to take responsibility and ownership. And we want to win, as we've said previously, we want to win the 6-year extension to this 4-year contract, because that's where we want to be with 10 years work. Feedback. I'd like some feedback, some suggested content for these. Anybody that wants to take one under their wing and deliver it. We want some ideas for promoting knowledge sharing. What do we find useful and what do we get value from? How we can use the forum better to increase collaboration across LU, Balfour Beatty, TFL. In the first instance, any of those feedback can come to me via email. So that's all I want to say about the knowledge sharing. Now we're going to move on to the main event. So we've got John O'Sullivan with us, who's going to give us a drainage delivery presentation. So John graduated with a bachelor's degree in civil engineering from Cork. I'm not sure if it's a coincidence that the first 2 presentations have been done by Irishmen. In historical parlance, I would say we'd be called cannon fodder, but on a serious note, John has an extensive CV, working initially across heavy civils projects and infrastructure projects. He joined ITT in 2013 and has ever since been the go-to guy for anything that's drainage related. So he's going to share some of his expertise today on some of his experience when he's been renewing the tube's extensive and varied drainage system over the last 7 or 8 years. So without further ado, I'll pass it over to John.
Thank you. Thank you very much, Damien. Thank you for the glowing reference. Yeah, it's hard to believe I've been here for 7 years, but seven very enjoyable years. So thank you for giving me the platform to pass some of the knowledge I've gained over the last 7 years working on Track Partnership and ITT, and passing some of my knowledge to wider audiences. So quickly went through the agenda for today. The first is, one thing we're going to look at is the purpose does track drainage serve. Second is design, so basically some of the design requirements which you need to look at in order for a good design. Thirdly, it's going to be materials used, some of the existing stuff and some of the new stuff we put in. And finally, we're going to look at renewal techniques, so some of the traditional open cut renewal techniques we do, and also some of the non-trenchless techniques, COPP lining, pipe jacking, etc. So what purpose does track journal serve? So I'll give people 30 seconds, 60 seconds just to throw some suggestions. There's 5 in all, and then I'll run through them. So I'll just give people 30 seconds or so to for some suggestions across what they think is the main purposes, and then I'll run through them. Yeah, so the first one is to maintain the integrity of the track formation and its performance. Secondly is to ensure the rainwater is effectively removed from track sections in open areas. Thirdly, to ensure the water rising through seepage and infiltration are efficiently removed from the track in tunnel areas. Fourthly is to cleanse the track bed by capturing fines. So the fines are obviously washed into the drainage trench and catch pits and picked up there. And finally, to prevent premature aging and signal failure. So yeah, I've seen a few come through there. A few people obviously have a bit of knowledge already. There's 2 types of main drainage. So there's positive and natural. So positive is basically pipe, channel, ditched drainage, and it's required when, in effect, there's no natural percolation through the ground. So it's where there's a solid invert to the track, so where you have a viaduct, you have bridge deck, tunnels, where the subgrade is impermeable. So if you have a silt or clay material, where the capacity of the subgrade to accept water is poor. So that's common when there's soft chalk, and also in areas of flood risk, which is, in effect is low points in the track. And then natural, in effect, is obviously the opposite, which is its natural ability relies on the ability of the ground to accept rainwater flows. So that's in areas where you have good sand, gravelly, good quality permeable chalk. Also, you can have sustainable drainage systems like soakaways as well. Moving on to the design. So there's 5 key requirements with the design as well. The first one to look at before you commence the design is to review history of flooding in the area, any reports on flooding and such like that. Then you review the site hydraulics. So the site hydraulics involves assessing the catchment in its entirety. So surveying the catchment, identifying the location of the pipe, the size of the pipes, and then modeling that existing catchment and seeing how it reacts to different types of storm events. So 1 in 5-year storms, 1 in 10-year storms, 1 in 50-year storms. Once you have that, then you can obviously see the impact the flooding has, and then whether you need to either upsize pipes to meet the requirements of the modeling that you've inputted. Once you have identified your proposal, then you can move on to review the condition of the existing pipes. So that in effect is you basically look at the condition of the existing pipes and the requirements of the proposed, and see in the catchment where you might be able to retain some pipes. For example, you might have a pipe which hydraulically works, but structurally, in effect, it has, say, holes, fractures. So it might work hydraulically and is the right size, but it might need some renewal work. So you might need to line it. Might not need a full renewal, but by establishing the structural severability issues of the catchment, you can identify what work you need to do. So then you can get a defined line of what you need to retain, what you need to renew, and then what you need to maybe rehabilitate by CIPP lining or slip lining. Number 4 is construction technique and buildability. That in effect is obviously making sure the design is buildable. We've had many instances where we've had designs issued for approval for construction. When we've done walk the site, we've realized that a lot of the design input, so for example, if open cut renewal, but there's signals in the way, channels to be installed, signals in the way, other places where you have insufficient space to install drainage through bridge abutments or through narrow 6 foots. So yeah, it's critical obviously that what you put down on an AFC drawing actually is buildable inside. And then finally, the last design requirement is highlight areas of high risk. So areas where you're excavating over Thames water sewers, areas where you might have potential asbestos intrusion, Japanese knotweed, stuff like that.
John, before we move on, there's a question
Yeah.
that's come up. So someone's asking, what do we do first? Generally, what's best practice, a BTR or to do the drainage before for a renewal?
Ideally, it'd be drainage first, particularly if it's pipe. If there's a risk that the drainage may be damaged by a track renewal, then obviously, yeah, you do the track first. That's generally the case when you install channel. I know they did the renewal at Wimbledon when they did pipe and track together, and I think the line of the channel was impacted while they're trying to do the track bit formation. And also up at Harrow as well, we commenced installing some channel, but once they did a P&C renewal, the channel basically moved and got damaged, so they ended up stopping the overnight renewal. We were doing the channel overnight renewal, and we've decided to do that post the works. So yeah, basically to answer your question, I would say as much as possible, especially if it's a pipe, but when it's channel, it's best if it goes in second.
All right, cheers.
So moving on to construction. So there's going to ask a question. There's three most common materials of the existing pipe and LU. What are they constructed of? So I'll give 30 seconds. So the three most common found pipe material on London Underground. This is the existing infrastructure, not of the new stuff we put in. So I'll give 60 seconds for that to see people's suggestions. So yeah, some good suggestions come through. Some, they're all in a way correct, but by far the most common one we find is clay. That's predominantly down to the fact that most of the pipes on the system are between 225 and 300. So that's generally what the clay pipes come in size. That's the kind of the size of pipe we use. If you go any larger than that, so if you go from 300 mil to 400 mil, you generally find them to be of concrete construction. So that's probably the second most common. And then thirdly, you have a lot of brickwork, especially brick over culverts in the subsurface. So anywhere like, especially down through the district line, a lot of over culverts there. So they can range in any size from 400, 450 mil diameter up as big as there's some down in the South Kensington platform, which are 1100 wide by 800 high. So yeah, quite big structures. They date back from 1860s. They're obviously they're there since the track went in the first day. And then also you find bits of cast iron, not very common, but there is bits here and there scattered within the infrastructure. So moving on to
Sorry, John. Before we move on, there's a couple of interesting questions. One from Declan is: does installing a drainage channel eliminate the need for crossfall when carrying out a BTR?
No, because you should always have crossfall, because it needs to fall in the direction of the drainage, doesn't it? If you don't have crossfall, then in effect it's probably just going to sit in the track bed.
Okay.
So it needs to be cut in the right direction to where the drainage is.
Right. Regardless,
that track channel will need to be below formation in order for it to be collected and properly work.
Okay, there's one from Zach as well. So at what point do we capture the effect of, I guess, infrastructure development around an area, as this can have an effect on site hydraulics?
So runoff from associated infrastructure, that would be picked up in the hydraulic modelling of the catchments, I assume.
Sorry, say that again?
So the micro drainage model will pick that up as part of the hydraulic modelling. So
right.
when you set all these storm events, runoff from associated infrastructure will be captured within that.
Okay.
So on to some of the new pipework we install. So generally, obviously, most common is plastic pipe. So there's two types of pipe we generally use. The first type on the left is a Rigitrack pipe. So that is a lightweight poly pipe twin wall ribbed. So it's very light. It's only 18 kgs for a 6 meter length. It's longer length, so it has fewer joints, but it does need coupling. So unlike the pipe on the right, which is a push fit connection, the pipe on the left needs a collar for every joint. So that's a bit more painful. It's measured by internal diameter, and it comes in varying sizes. So it comes from 150 mil up to 600 mil. But it is more environmentally friendly than the pipe on the right because it incorporates recycled plastic in its makeup. So the pipe on the right is called, it comes in two types. So it's called a Terra line, which is a solid pipe, or a Terra drain, which is in effect a filter pipe. It's heavy duty. It's quite a bit heavier than the poly pipe. So a length of 3 meter length of 280 is about 40 kgs. So it's quite a bit heavier, but it's very durable and very heavy duty. So it's a better, probably long-term life cycle than it does of a poly pipe. It comes in different classes as well. It comes in an SDR11 or SDR17. SDR11 is a shallower depth and for areas of higher loading. Moving on to channel. So channel comes in two different sizes. So it comes in a 150 or 300 mil internal diameter. Each unit, whether it's a riser or a base, is 750 mil long. And usually the makeup is one base, 3 risers and a cover. That's in order for it to get below the track formation and in effect drain the formation correctly. One thing about channel is there's a lot of manual handling. So for example, if you're putting in a 3 meter length of pipe, if you're installing channel of 3 risers in the same area, you're installing 20 units, including lids. So that means there's a lot of on-site storage required to lay out the channel and prep works, or more space is required on the trains in comparison to pipe. It's also quite more expensive, approximately 10 times per meter length than it is of a Demco pipe, which is the Terra line pipe, the heavy duty stuff. Advantage of channel is its greater storage capacity. It works better hydraulically in flatter catchments, and also due to the extra storage capacity, it doesn't need to be as deep. So it can be installed shallower. And also one other point is it's supposedly easy to maintain, but that's a bit debatable because we've had issues trying to clean it out in the past after we installed it. And finally, the other pipe we use is ductile iron, which generally is only used in shallow UTXs and in 4-foot drainage. So we've used a bit of it in B2F and we've installed drainage up to 4 foot. But other than that, it's not really used very often.
Before we move on as well, John, a couple questions. Yeah. Simon's asking, why do we install channel rather than pipe? I guess, what's the decision process behind that?
I guess it's probably down to the hydraulics. So basically, yeah, it has greater storage capacity. So even, I guess, if you install it and you don't need the entire capacity, obviously with climate change and stuff, you know that there's a built-in space and storage for the future. So you might be installing pipe work, which might be satisfactory for now, but maybe in 20 years' time, due to climate change, your hydraulic volumes you need to deal with might be actually larger. So at least you've built in capacity in a channel. And as I said, it also works better in flatter catchments. So it's just better to install in flatter catchments than it is pipe. So they're the two main design reasons.
Right. Perfect. Lee also asks, is there an opportunity to use, I guess, GRP channel in the future instead of concrete channel? Maybe keep the cost down, manual handling down.
Yeah, that was something that was discussed at the drainage hackathon a few months back.
Okay.
We, the supplier of the concrete channel, who was there, he said GRP would definitely be an option, but we need to get back to him with like almost set meterages of what kind of meters a channel we'd require. Otherwise, it wouldn't be worthwhile basically going behind doing the design concept if we were only going to order, say, 100 meters of channel. But if there's a big demand for it, then yeah, it was definitely something you could look into. Yeah, and obviously that would be a big help because it would eliminate the manual handling.
Yeah.
But we had trial in our last possession. We did trial a channel grab, which worked quite well. So that eliminated a lot of the manual handling. You still obviously need to set the base of the channel, but all the risers can be lifted in using the channel grab, and it worked quite well on that possession.
Okay, another one, I think you touched on this as well. What was the cost comparison between pipe and channel?
Per unit rate, you're probably talking, so obviously material itself is about 10 times more expensive, but
Okay.
in overall possession, you're probably talking per unit rate 30-40%.
Right, okay.
So moving on to the next slide, which is running through the materials we use. So starting from formation up, the geotextile we install is Terratex, same as we use predominantly used for the track. So this is to prevent the movement and loss of fines from the track sub base. On the drainage terrain, you overlap the downstream geotextile on top of the upstream. This is to prevent ingress of subgrade fines, and should be lapped with the track geotextile or else rolled down protected. So obviously, if the BTR hasn't happened before the drainage, what generally happens is the terrain is brought up to track formation, rolled up in a 500mm lap, and drainage guttering placed on top. So when the track renewal happens, in the drainage terrain can be lapped into the track terrain, giving integrity and uniformity of terrain throughout the track formation. If the drainage happens post, then the drainage terrain needs to be lapped into the track terrain, which should have a bit of through overlap. So you have next up is the pipe bedding. So if you look at the picture in the top of the slide, that's a pipe laid on a shingle bed. So the shingle bed is generally 100mm deep. It's a single size filter, so it's usually a 1020 shingle. In areas where you can reduce the shingle bed down to 50mm, but in areas where you have to deliver reduces less than 50mm, it needs to be bedded on a C40 haunch. Otherwise, you don't get this effective support on the pipe, and it will just settle. So the backfill. So when you backfill a pipe, you have to give a minimum of 100mm bed and surround. But generally, the pipe would be well below, but a couple of mil below the formation. So generally, when you have a filter drain, the filter media, which is the same as the bedding media, will be brought up to formation level, and then it's just basically track ballast from there. In the carrier draining, you can basically backfill on top with a selected fill. So in effect, it's just good quality material with no rocks, bricks, tree roots, stuff like that. So that's basically for carrier drains. And that's what you can see the guttering on the left, which is basically places on the picture on the left, which is placed at track formation, like that's a week 47 possession. Then moving on to catch pits. So catch pits required to inspect and maintain pipes. They should be no more than 30-meter spacing. So that's basically generally for new designs. There should be a change in direction or a pipe size, and they should have a sump to collect debris and silt. You don't need to have every catch pit or every chamber as a catch pit, but you should have as many as possible. I think at least one every 3 or 4. It also provides an access for pipe inspection and maintenance. So obviously, if you need to carry out any CCTV and jetting, obviously the chambers need to be of a certain size, which is generally 1200 by 600, so you can get man entry to clean and jet. Existing chambers are generally made up of brick, concrete rings, or mass concrete, and new catch pits are generally cubist GRP, so they're like a 1200 by 600mm opening, and they're 150 deep. It's the picture of one of them there on the right. So the GRP rings at 150mm depth, and then they're just built up to the sleeper level as required. The top ring has a recess, so you can fit a GRP cover. Cubists also supply reduced cubist catch pits, so they're 530 by 380 internal diameter. They're non-accessible, so they can only be manuals. You also have a combination. It's like a reduced catch pit, so you can have standard rings at the bottom, then you have a reduced slab with reduced catch pits on top. So that in effect gives more space as you come up to the track formation. So if you have areas where you have severe cuts and sleepers, you can reduce your, say, if you have a standard catch pit there, you can reduce that down, put in a reducing slab, and then build it back up and reduce rings, so giving you more space for sleepers, and then prevent cutting sleepers in any excessive We also use 450 by 450 reduced concrete catchment rings. They're generally used in the 4-foot areas because the GRP can't be used in 4-foot locations due to the loading, the train loading in those areas. Sometimes we use concrete rings, but generally not if we're building brand new catchments. The only time we generally use concrete rings are when we're modifying existing catchments. Maybe we're replacing a cracked top riser of an existing chamber. That's where we might use a concrete ring, but generally it's GRP most of the time.
Again, John, just a couple of questions. You mentioned carrier drain. What's the difference between a carrier drain and normal track drainage?
So basically, well, a track drainage is made up of carrier drain and a collector drain. So basically, a carrier drain in effect is a solid wall pipe. It doesn't drain the track, while a collector drain or a filter drain basically has perforations, which allows it to pick up water from the adjacent track. So basically, one's a collector, one's a carrier, and both of those components make up track drainage. So
Okay, and then a question from Craig. What is the reason we don't use trench liner? Isn't that a cheaper alternative? I'm not sure if you know about it. Trench liner. Yeah, I think it might be for the geotextile.
Oh, the geotextile. Yeah, I'm not really sure. That's sorry.
It's a geotextile used on network rail. Yeah.
Is it? I don't know. Is there any main benefits of it? I know. It's just for uniformity. We used Terratex. It's basically because it has the same spec as what we require for the drainage. So we just for ease, we use the same as they do for the track drainage. For the track renewal even.
Okay, maybe it's something we can look at, I guess.
Yeah.
Yep.
So moving on to some of the traditional open cut. So traditional open cut basically is excavation from track level, and it involves removing the existing, either removing the existing drainage or installing brand new drainage. But by doing that, you install new pipe, new backfill material, and new ballast. So in effect, giving a brand new drainage pad, and is almost guaranteed to work. It has a long asset life, and sometimes it's the only way you can address hydraulic modeling issues. So, as I said, if you can line pipe is fine, but obviously you can't upsize pipe by lining. So the only way you can upsize pipe generally is by open cut renewal. So that's why we use it. Obviously, some instances as well, the pipes cannot be lined, so open cut renewal is the only option you have. So we deliver these in either possession or engineering hours. So possession, typically, we deliver 30 to 150 meters per working crew in a 52-hour closure. This meterage would be less than a 6 foot. This is down to the fact that there's a restriction imposed by the ORR a couple of years ago, so we can't have any engineering trains stabled next to open trenches. So what we've done to work around that, the new method is we have to dig into RV boxes and then run up to a train which is stabled away from the open trench, and then it's basically loaded into the train from there, and then the machine will travel back. So generally for one gang working crew, we have one dig machine. So it's generally a 118 because you need an offset machine to dig sets of drainage. And you'll have a service machine, so generally a SK135 or PC118 with a box and trailer which is used to ferry ballast and shingle from the train to the quarry work area. As an alternative, if you obviously ideally we use trains, but sometimes obviously we share possessions with BTR, so we generally have limited train resource, so or sometimes no train resource. So what you can do if you have access close by is you can use RVs or boxes and trailers to run back to a flux machine and recycle and carry materials back and forth that way, if access permits. Engineering hours, yeah.
Just quickly, you mentioned something about how we've had to change methodology because of the ORR. How
Yeah.
has that impacted our delivery volumes over a weekend?
Yeah, I would say it would probably reduce. So for a crew would generally get 130 to 150 meters. I would say you'd be closer to about 100 meters now. So probably 30% reduction.
Okay.
Engineering hours, we do on approximate, depending on what we're on this site layout and such, you can get between 2 meters and 8 meters a night. 8 meters obviously being a really good output. Historically, delivery was using 0.8 to 1 ton mini digger, which would excavate onto track trolleys, so 1 ton bags and track trolleys, and then push back to the nearest access point, where it would be loaded using a HIAB, removed from the site using a HIAB, and then the HIAB would basically drop down material and that would be pushed back. Obviously, that has a lot of manual handling and a lot of basically manual handling, manual, just a lot of pushing and pulling. So we're trying to mechanize stuff as much as possible going forward. So, for example, at Loughton, um, we're using solely ORVs, so there's no track trolleys. So they on track via RAP, basically just west of the station, and travel up to the work site. So we have TB250, 118, which ferries material up and back, and then a 138, which is loading the 118 with material. That works very well at Loughton because, as I said, you're quite close to the access point. If you're any more than 300 or 400 meters away, obviously it wouldn't really work because obviously the travel time back and forth, and also you need somewhere to on-track RVs, which you also have at Loughton. So if you don't have a good close proximity to an access point, then you need a good storage area where you can on-track the machines, basically in effect right beside where you're working. Sometimes obviously that's not easy to find either, because we have outstanding renewal near Loughton, but unfortunately there's no storage areas, and it's about 700 meters from the nearest access point, so it's just not achievable in engineering hours. Yeah, so basically that's all to say in traditional open cut. So just to move on, we're going to have a quick quiz. I'm going to hand over to Vid to run you through this. So yeah, all yours, Vid.
Cheers, John. So if everyone can go on kahoot.it and then enter this game pin, you should be able to log in. I'm just going to share my actual screen with you. Just bear with me. Can everyone see that? John, can you see that? Oh, there they are.
Yeah, I can, yeah.
I've seen Jacob joined, Len's joined, Matt's joined. I'll wait for a couple of minutes to let more people join and then we'll start the game. Okay, wait for one more player. Okay. So we'll just start this with 20 players. Let's see how this goes. Here we go. So this is the drainage knowledge sharing quiz. 3 questions, hope you're ready. So how many meters of drainage are there on the London Underground? Is it 558,000 meters, 0 meters, 200,000 meters, or 12,459? Got 16 answers. There you go, 558,000. 9 people got it right, pretty impressive. Moving on. Let's see. Oh, Rudy was the quickest. Nice one. So what is the design overlap between track and drainage geotextile? Is it 300 millimeters, 150 millimeters, 250, or it doesn't matter? I hope no one picks that one. There we go. 10 people got it right. 10 people weren't listening, unfortunately. So let's see the scoreboard. Oh, Matt jumped right into the front with Owen in a close second. Final question. What is the total amount of water in litres pumped out of LU in one day? 500,000, 5 million, 85 million, or 35 million? There you go, 5 people got it right. 85 million was the right answer. So let's see who's made the podium. In third place, we have Dino. Nice one. Second place, Owen. Very impressive. And number 1 is Matt. Nice one, Matt. I think John's got a present for you. Quick runners up, Jonathan and Ang. So just stop sharing that and then go back to the presentation. Hope you guys enjoyed that. Back to you, John.
Cheers, Vid. Thanks for that. So moving on, I'm going to briefly talk about the 3 most common non-dig techniques we use on London Underground. So the first one, and the most common, probably 95% of all non-dig techniques we use, is cured in place pipe. What better is basically also known as UV lining. So there's two main types of liner we use. It's either a Sartex liner or an impreg liner. Basically, there's much of a muchness, similar strain characteristics, but the Sartex liner is more durable. So basically, if you look up to the top cross section of a Sartex liner, the green area in effect is it's fiberglass sheets with resin embedded, and then there's an inner and outer foil which protects the liner. The outer foil during transport into environmental conditions like the sun and stuff, and then the inner bag helps during installation and calibration of the liner. Varying thicknesses depending on the loading requirements. So before commencing on site, it's essential that you carry out a pre-CCD survey and jetting to confirm that the pipe you plan to line is actually lineable. So once you confirm that, also another criteria before you start on site is the lining company should supply calculations confirming the thickness of the liner to be used and whether it can withstand the train loadings required. Then the calculations of the liner needs to be sent to the PE for checking. So once you've satisfied that the pipe is ready to be lined, a liner is pulled into the hose pipe. So that's basically done by having a winch at one end and the liner positioned at the other, and then it's basically just strap placed around the liner, and then it's winched in through the hose pipe. So once it's put in, a light train is inserted. So the light train is the instrument in the middle picture. So basically that's just an instrument with UV bulbs which cure the liner. So once the light train is inserted, you fit the end cap. So an end cap is shown in the picture on the left. So they're used to calibrate the liner. So basically, once they're fitted either end, the light train's in, the liner is then inflated. So it's inflated so that it's tied to the existing circumference of the hose pipe. So it's a tight fit. So basically, the calibration and the curing is controlled by a lorry-mounted equipment, which is generally at road level, but there's a limit to the distance it can be from the location you're lining. So generally, it can't be more than 300 meters away, because that's the set amount of extension it has. If it's any longer, then the pods will need to be lifted on track by the nearest access point and then brought to site using an ORV. So curing time depends obviously on the diameter and the thickness, but generally you're looking at 700 to 800 millimeters per minute. So it's quite quick. So in an engineering hour shift, you can cure of a 225, you could probably cure up to 40, 50 meters. No problem, because we cured at Acton Town platform grounds. There's 35-meter, 600 brick culverts. We cured them in engineering hours. Like, so you're talking of circumference of that in comparison to 225 pipe. That was pushing the limits, to be fair, but yeah, you've quite a big output, and you can all be done in engineering hours. Once the liner was cured, the internal lining bag is pulled out. Sartex did do a liner currently, which is called Sartex Premium, I think is the exact name of it. But basically, in effect, you don't have the inner bag, because the inner bag, in effect, seals to the membrane. So it's basically one unit once the line is complete. So you don't have to worry about pulling out the inner bag. So because what's happened previously is inner bags haven't been pulled out by the lining contractor we've used, and they've washed down to pump stations downstream and then got cut up in the pumps. And obviously, if that happens around pump side and the pump fails, then you can have serious issues. Some pipes, if they're a collector, they need to be perforated. So this is carried out by using a robotic cutter, which basically is in effect just a little robot which drives into the pipe and has a cutting bit on it, and it drills perforations in the crown of the pipe. So it drills holes, either cuts or drills holes, and it just needs to satisfy the LU standards, which is 1,000 millimeters squared per meter into pipe. Also, what you have when you line a lot of the brick culverts in the subsurface area, especially through platform grounds, is you have a lot of laterals coming in. So they'll need to be reopened as well once the lining is taking place. So they're basically marked up before the liners, pre-lining, so you know the exact locations, and then they're reopened once the lining is taking place. So then the last picture on the right, it just shows a complete liner. So that's how a line pipe will look once it's fully lined. So that has a life expectancy of, I think it says 50, 60 years, but speaking to some of the suppliers are saying probably get upwards of 100 years. So there's a big life on a liner. So moving on to slip lining. So slip lining is the process of inserting a new pipe inside the hose pipe. So basically, normally it's done with a HDPE pipe, or sometimes we need to use steel to reduce the pipe diameter. So obviously, by inserting a pipe inside a hose pipe, we're reducing the size of that pipe, so that can impact the hydraulics. So by installing the steel pipe, obviously it's going to be thinner because of its characteristics. So that'll help if you need extra volume for hydraulics to work. So basically, the effect is just pushed into a hose pipe, and then it's either welded together or tap screwed. Normally, the pipe used for slip lining is about 150 mil or so smaller than the existing hose pipe. So that means you have a void between the two. So you can see the two diagrams. The one on the left, which the grey area is they call it the annulus. So that's the void left between the hose pipe and this pipe you've slip lined. That needs to be filled because there's a void. So if it's a carrier pipe, it will be grouted. So you basically create holes every, say, 5 meters, and you pump grout in to seal up that void. If it needs to be perforated, so for example, if you have incoming laterals into the pipe, into the existing hose pipe, which need to be maintained, it'll need to be filled with shingle. So you use equipment called it's a shingle blowing equipment, Venturi system. That's what I was looking for, which basically blows shingle using compressed air. So you need to just create openings on top of the culvert or pipe every 5 meters, and then blow shingle either way. In short runs, it may be basically pushed in by hand, because it's you can just push it in sections. And in longer sections, will either need to be winched in, or sometimes hydraulic pushed in using a hydraulic jack. You can achieve up to 15 meters in an engineering hour shift of slip lining. And it's quite useful, as I said, if it's, for example, section under points, like we slip line a section 125 meters under 267 points just east of South Kensington last year, which worked quite well. It also basically a temporary solution. So, for example, if you're doing a BTR, you can't get in to renew the pipe, you can slip line the existing hose pipe to, in effect, protect and have continuity in the system, so giving a path for water flow in case any damage does occur during the BTR. Moving on to the last one, which is pipe jacking. So pipe jacking, in effect, is another way of inserting a new pipe inside a hose pipe, but this is done using hydraulic ram. So it can be steel or HDPE, just like slip lining, and it's generally used on longer lengths. So slip lining is used in shorter lengths, pipe jacking in longer lengths, or if the hose pipe has more severe deformations that you can't winch through or you can't push through. If pipe jacking is to be considered, you need both the launch and reception chambers to be of a certain size. So minimum of 1200 mil. So in pipe jacking, you can see in the top picture, you have the that yellow frame that sits inside, and that's basically in effect a hydraulic jack with a truss plate on the rear wall. So the chamber needs have to be of a good construction, so it can take the thrust of the jack as it pushes the pipe forward. So what you see there, you have the actual jack arm halfway down the attachment, so that'll be pulled back. You drop in a section of pipe and that's jack forward, and then weld it onto the. You drop in another section, weld that on, and then jack it forward. You continue doing that until the whole run is lined. Generally, because of the size of the chambers and the frame we use, you use pipe sections of about 800 to 900 mil. If using steel pipe, it will generally be welded, and if it's plastic pipe, it will be self-tapping screws or pegs. You do need quite a bit of a storage area for the plant, because as well as having the kit inside the catch pit, you also need obviously pumps. You need a power pack to actually operate the hydraulic jack. So yeah, you need good storage areas adjacent to where you're doing it. The last three pictures just show some pipe jacking we carried out at Acton Town in 2016. So basically, as part of the design, they noticed that there's a brick culvert running under 44 points just west of Acton Town, which was in really bad condition. So it was a 600 brick culvert, had deformities of up to 30%, and it ran just west of Acton Town on the Piccadilly line. So obviously, very high risk area. If that culvert was to go, then obviously you'd have closure of the line because of the diameter of the culvert as well. You're talking a massive size of culvert. So what was proposed was slip lining of pipe jacking of the existing culvert using a 400 mil steel pipe. So basically, what they did is they adapted one or two chambers on the existing run, which allowed them to insert the pipe jacking equipment shown in the picture, and then they jacked 900 mil sections in and flash bolt welded each joint. So over the course of that weekend, they installed 94 meters, and then they grouted the annulus between the hose pipe and the new steel pipe in engineering hours after. Yeah, so that was probably one of the biggest pipe jacking jobs we did on the network, and
John,
quite successful.
there's a couple questions that are coming up. So one of them from Simon is, why can't we do the CCTV ourselves and stuff? Why do we, I guess, use third parties?
Yeah, so we tried that back 3 or 4 years ago, and yeah, carrying out the CCTV on site. But what it was by the time so basically if you go to one of the subcontractors, they'll do a CCTV survey of probably a couple hundred meters in the night, and they'll do a CCTV report grading the pipe structurally and serviceability for 900 quid. We just couldn't match that. We couldn't make that cost efficient. We did attempt to try and bring it in-house, but by the time we looked at it, it just didn't work out cost effectively. So that's why we just went back to using subcontractors, because they in effect they do that almost at a loss, just to keep us kind of happy and to keep us interested in giving them more lucrative stuff, like some more UV lining, pipe jacking. So they almost do the CCTV for free, not for free, but at almost a loss. So that's why we couldn't really compete with them.
Right. Okay. On the back of all these non-dig techniques as well, and because we've had to change our methodology slightly, are we kind of using these techniques more now to increase our output after changing the methodology, or aren't they always suitable?
No, exactly. They're only limited. Obviously, more often than not, it'll be open cut renewal what we do. Probably still be 70-80% of what we do, because a lot of the existing infrastructure is such that it can't be lined. Obviously, you can't. There's no point lining a pipe if it hydraulically doesn't work. If there's backfall in it, you need. So a lot of the existing infrastructure needs full, like basically addressing big time. So you can't just line a section of pipe because it won't basically improve the hydraulics of the catchment. So that's why we need to renew a lot of stuff, because either it's hydraulically inadequate or also structurally, so it can't be lined anyway. Hence why you need to open cut renewal.
All right. Okay.
So that's basically the three main non-dig techniques we use. Then the next slide just shows a couple of instances where obviously when things do go wrong, when you do have inadequate drainage in areas. Lucky enough, I did search through the internet and I did ask some of the other project engineering team of any instances they know of flooding in the last 10 years or so on London Underground, and thankfully there's been none. So that's a good indication of what we're doing is having a big impact. So the two pictures I've showed you are from Network Rail. One is basically, as you can see, surface flooding. It's understood that the cause of flooding was from the adjacent fields, which basically flowed onto the track, and the track drainage was unable to discharge the quantity of water, thus causing flooding in the track. The second one, that was at Sheffield. The second one was Guildford. Again, the water within the track drainage and embankment wasn't controlled sufficiently, which in effect caused slow failure. And obviously, as you can see, just obviously the whole line and everything was affected. So massive impact on customers and lost customer hours. And yeah.
Again, John, before we move on as well, I think Christmas kind of made a statement, I think, that there is a potential project for CCTV for the whole network. So maybe that's something we should actually relook at again, and then see if it is still cost effective to give out to third parties. I thought I'd just capture that.
Yeah. That's definitely worth looking at. Yeah, definitely. And finally, the last slide is basically just kind of an awareness and some help from everybody who's listening today, and help that we could generally do from, basically help for us as a track from track drainage, for what you guys could do when you're on track walks or carrying out general track renewals. Just some quick bullet points. So reporting of any local depressions or holes in the ballast, settlement affecting track or lost access or ballast. So if there's any ballast shoulders which just disappear and doesn't have any sense to it, there's obviously must be a reason for that. It's usually underlying drainage issues. Any drips or significant wet patches on tunnel walls, standing water or wet beds, obviously major issue. Any bulges or slippages from earth structures, catch pits with broken or missing covers. Also catch pits which have plywood inside, which are supported. Often the case where you've had catch pits which are damaged, people have just done a temporary repair. They've just basically wedged it with two pieces of ply either side and a bit of 4x2. Obviously, just kind of hiding over the issue, but that can obviously fail and then cause a big void under the track. And also standing water within catch pits, where you can't see the pipe. Obviously, that's again highlighting that there's an issue downstream, a blockage because the water is just standing, not getting away. And also high levels of silt and debris. So obviously, if a catch is full of silt, it can't carry out its duty. The water can't get through, and then basically the water just standing, it's not functioning correctly as a drainage system. So they're just a couple of things that just keep in mind when you are out carrying out track walks or renewals. And also another point is any kind of damage carried out throughout the weekend or overnight, just to report it immediately so it can be rectified, and we don't have situations leading to wet beds and surface water flooding due to unreported issues. So in summary, track drainage plays a vital role in the life cycle of track and shouldn't be seen as a secondary to track. A good design is paramount to good delivery. and there's numerous varied renewal techniques available to rehabilitate and renew existing drainage. So thank you for listening. I hope you found it interesting in basically open up your eyes to a bit more knowledge of what we do on the renewals and understanding of the techniques used. If you have any more questions outside of this, feel free to drop me an email and I'll try and answer your questions as good as I can. And yeah, any questions, just let me know. And yeah, thank you for listening and enjoy the rest of your weekend.
Cheers, John. I think, Damo, you want to say a few words, don't you? I'll just unmute you.
Yeah, no, it's just a question. John touched on Wimbledon Platform 4. I actually worked on that job. Is there a case, John, with better planning? Because working on that job, we were putting in, if we'd installed a pipe on that job and if we'd looked at the design beforehand with proper planning, could we have done both on the one weekend better than we did?
I don't know the ins and outs of that design, Damien, but I did think I heard in the office that the reason we need a channel there is that drainage system outfalls onto network rail, and there's historic issues with the network rail drainage not working. So the channel, in effect, will act as a storage area for any water filtrating from the LU track. So it's basically stored in the channel, and then basically slowly gets away into the network rail system. I think that's the reason channel was installed in that area.
All right, so it wasn't a client preference for channel, because I know Anthony Fernie was very keen to install channel drainage throughout the system.
No, I think in that particular area, yeah, it was due to the outfall to network rail was the issue. So they wanted as much storage as possible, so there's a backup area for the water to hold before it can percolate out to network rail.
All right, thank you. Thank you, John. Who would have thought there was so much involved in digging a ditch beside the railway, but it's quite impressive. So hopefully this will go to help with our lack of drainage appreciation across the PWA delivery teams. So just looking at that slide there, so next week, we're looking forward to having Dan Anus next week. So he's going to be delivering on deep tube renewals and unique challenges around working in the tube. Dan has 16 years experience in predominantly concrete at track. And as a site engineer, we both worked in Track Alliance, delivering DTR projects across the Central Line and the Victoria Line. So when we found our feet on that project, we went from delivering 1 to 2 sleepers per night to up to 14 sleepers per night on that during engineering hours. So Dan is a true specialist in his field. We all know we see instant experts come and go. They come in and deliver a couple of projects and leave thinking that everything done is the real deal. He's got 16 years in the tube delivering projects, so he's a great asset to the team, and he'll be a key part in tendering for the overnight BTR stuff when the project comes up. And that's about it. So thank you very much for dialing in. It's great to see TDU involvement and our colleagues on London Underground getting involved. Again, I'd like someone to volunteer to come forward and share your expertise, because there's expertise throughout the business that I'm not aware of. So anyone that has anything to bring to the table, we'd invite any emails in to let me know and we can chase it up. Thank you very much.
Thank you.
We do.
No, I need to pull up the scale.